Buddhi is a Sanskrit word which implies discernment, clarity, and higher understanding. It primarily means higher intellect or intelligence. This model, Buddhi 128K chat, seems quite interesting as it utilizes few new concepts. It is a general purpose first chat model with 128K context length window, and that is why you would need at least 70 to 80 GB VRAM in order to run it. Their GitHub repo and their this model card mentions that you can run it by just bringing the context length down to 75K on 40 GB VRAM. I have tried it on my NVIDIA RTX A6000 with 48 GB of VRAM. I was unable to run it. So I believe you at least need 70 to 80 GB for this model to run, but seems very interesting. I wish I would have that much GPU to try it out, but anyway, we can do the second best thing. We can just go into the detail of this model and see what exactly it implies. This model is meticulously fine-tuned on the Mistral 7 billion instruct and optimized to handle an extended context length of up to 128K tokens using the innovative YARN technique. And YARN stands for yet another rope extension. This enhancement allows Buddhi to maintain a deeper understanding of context in long documents or conversations, making it particularly adept at tasks requiring extensive context retention, such as comprehensive document summarization, detailed narrative generation, and intricate question answering. The Buddhi 128K chat model is fine tuned on the Mistral 7 billion instruct based model, and they have selected the Mistral 7 billion instruct as a parent model due to its superior reasoning capabilities. And this is bit of a architectural diagram of it, where if you see that the architecture of Mistral 7 billion model includes features like grouped query attention and byte fallback BPE tokenizer. Originally, this model has 32K maximum position embeddings. So to increase the context size to 128K, they needed to modify the positional embeddings, which is where YARN comes into play. And in their approach, they utilize the NTK aware technique, which recommends alternative interpolation techniques for positional interpolation. One experimentation involved dynamic yarn, suggesting the dynamic value of the S scale factor. This is because during inference, the sequence length changes by 1 after every word prediction. By integrating position embeddings with the Mistral 7 billion instruct based model, they achieved the 128K model, and that is where the magic lies. And then additionally, they fine-tuned the model on their dataset to contribute one of the very few 128K chat-based model available in the open source community with greater reasoning capabilities than all of it. And the experiments which I have seen and some of the benchmarks, the model looks quite good. Now, coming back to the dataset side of things, that is quite interesting a bit too, because not only the dataset seems quite interesting, but so for the construction of their model, the dataset employed encompasses three distinct sections, meticulously assembled to cater specifically to chat model requirements. The initial segment draws upon Stack Exchange, presenting data as question and answer pairs. To enhance readability and adaptability for chat applications, they utilize Mistral model to refine the answer formatting within this segment. And then the later two parts adopt the Alpaca formatting style, focusing on generating a context-driven conversational framework. And this section utilizes a PG19 dataset sourced from the Hugging Face as the foundational context. The distinguishing factor between them lies in the source of the question answer pairs. While one part employs GPT-C for generating these pairs and the other leverages GPT-4. So this strategic composition of the dataset ensures a comprehensive and diverse conversational scope tailored to optimize the chat model's performance across a wide array of dialogue scenarios. Now, this is the whole architectural background of it. Let me quickly show you the notebook which they have shared, which you can use to run this model. So as I mentioned earlier, you would at least need 70 to 80 GB VRAM to run full model, but they say that you can even go with 35 GB, 30 to 35 GB, but it doesn't work. And I might be able to show you some of the proof to there later on, but let me first describe how you can do it. It's very straightforward. They are using VLLM. If you don't know what VLLM is, I have done heaps of videos on it. Please check the channel. So they are just installing the VLLM. If you are lucky enough to have A100, you can simply uncomment this flash attention, and then from there I'm just going down. This is where they are importing the model, and once the model is imported, they are just collecting some of the cache and that sort of stuff, setting some hyperparameters, and this is the prompt they are using and generating the output from LLM, and then printing the response out. It's very simple. You can also calculate the number of tokens here, and then there are few other experiments, like this is a long essay, and this is I was yearning to try it out, but I couldn't due to the out of memory error I received. And this is another experiment, and if you are somehow running it in Colab, but you would need Colab Pro, you can't run it on the free version. So if somehow you have the access, you cannot run it in the same Colab, otherwise you will start getting out of memory error. So run the first and second experiment as mentioned in this notebook, and then run the third one. I will drop the link to their model card. From there you can access this Colab. So this is the third one, and this is I really wanted to try it out too, that it has just given it a book, and with the help of this chat model, it has been summarized for the long context. Amazing stuff. And I also tried it out. Let me quickly show you. So I tried it out in my own notebook locally. I'm running NVIDIA RTX A6000. So I tried it with VLLM, it didn't work. Then I tried it out with transformers, it didn't work. So I think it's all about the VRAM. Even with 48 GB of VRAM, unfortunately I was unable to run it. But I will keep trying, and if you are the creator of this model, please reach out if there is any other way I could reduce the context length, or could I run it. It will be awesome. Or if it is in context version, let me know. I couldn't find it on your model card. It is so new, understandably. So that is something we need to check it out. But anyway, I'm quite impressed by the model, especially the way they have configured it with rope. And by the way, if you want to learn more about rope, I have done a very simple to understand video on this rotary position embedding or rope. So please do check out the channel. You should be able to see it. Also, towards the end, I really want to give a huge thanks to Massed Compute, who provided me this GPU with 48 GB of VRAM, which I was able to try it out. If you're looking to rent out a GPU, I will drop the link to their website and a discount coupon of 50%, which you can use to rent some GPUs on affordable prices. That's it, guys. If you like the content, please consider subscribing to the channel. And if you're already subscribed, please share it among your network, as it helps a lot. Thanks for watching.